go with the rest of stuff. Okay, which of the following error is an example of analytical error? Malfunction of microprocessor that affects accuracy in testing is correct answer. Okay. Okay, going to clear that. And then, okay, now what does control means? Standard means that I mentioned before. Control represent a spacement with a known value that is similar in composition, for example, to the patient's blood. Okay, we are using control serum in the clinical laboratory standards, okay, and calibrators, and control represent a spacements with a known value that is similar in composition to the patient's blood. And controls are the best measurements of precisions. Okay, if you know, okay, and the level of the samples, which is control, then you are going to measure the same test repeatedly 10 times, 20 times, and see how close one another's, the results, okay? And which give you the precise of the test. Okay, now calibrator or is other kind of the samples that we are using. Calibration is the comparison of an instrument measure or reading to a known physical constants. Okay, standards are highly purified substances of a known composition. Standard may differ from a control because also the control is known. The level of the control is also known. However, the standards may be differ from the controls. Okay, and the standards are the best way to measure the accuracy. Okay, in terms of the standards, you may have different level of the test. Let's say I'm going to show you a low level and high level of the same test, and then you are measure a different level of the same test and see whether how is close to the target values. Okay, and okay, standards are used to establish reference points in the concentration in the construction of the graphs in order to calculate the test results. In most instruments, it is done automatically. You don't need to create a graph, okay, in the clinical laboratory. However, in some rare tests or the tests that you are doing manually, you have to create a graph for each test, okay, by using the standards. Now I am going to show you. Last day I was talking about calibration and standards, but I have experienced some internet problems, okay? Okay, now I am going to talk about the standards. Standards are highly purified substances of a known composition, okay? We are using standards to measure a level of unknown tests. Now I am going to show you here, okay? Let's say if you need to measure the level of the glucose in your samples, in patient samples, okay? And for that, you need to prepare a graph by using different um, level of the glucose. Okay, as you see here, now I am going to prepare different standards which contain 50 milligram of the glucose, 100 milligram of the glucose, 150, 300, and 500 different concentration of the glucose included in different standards. And then I am going to measure each of these standards, absorbance of each standards via spectrophotometry. Okay, I know the level of each standards. Okay, now I am here, as you see, I labeled them. And then once I obtain the absorbance of each standard, now I am going to also demonstrate the absorbance of each standard and then created a graph. Now my graph is ready, and then I have a patient samples. I don't know the amount of the glucose in such samples. What I'm gonna do, I am gonna measure the absorbance of the patient samples. Let's say I measured 0.45, okay, and absorbance of the unknown samples. And then here the 0.5 and 0.4 and 0.5, right? Now I am going to come here. Let's see, here is the 0.45, and then the level of the glucose in the patient samples will be 150 milligram deciliter. Okay, if you get the absorbance 0.65, okay, and then you are going to come here and then come down and about 220 milligram deciliters. First, you prepare a graph by using the standards, okay, and then these graphs help you to obtain the level of glucose in each unknown samples. You can prepare such graphs for each kind of lab test. Okay. Okay, now sensitivity. Okay, we have 15 minutes. And specificity. You may heard such definitions before, but sensitivity is the proportion of cases with a specific disease or condition that gives positive test results. Okay, let's say you have 100 patients with COVID, okay, COVID patients, and you discover a new COVID test, okay, and you know that these COVID patients, they confirm it by DNA test. You are sure that they are a COVID positive patients, okay? And now you are using your new test to ensure how many of them are positive. If you have 100 COVID patients, okay, and you test these patients by a new test, okay, and if this and the sensitivity means the proportion of cases, okay, with a specific disease, with a COVID, as I give an example, okay, that give positive test means sensitivity. If 90% of your tests are positive in COVID patients, that means the sensitivity of your test is 90%. Okay, specificity is the proportion of case with absence of the specific disease or condition that give a negative test result. Okay, you have healthy patients, healthy population that you are sure that they are not COVID patients, and you take a samples from this healthy population and test with a COVID test. Okay, if they are all negative, okay, the proportion of negativity, okay, is the specificity. Okay, let's say you measure, you test it with COVID test, and about 70% of the patient was negative. That means the specificity your test is 70%. Okay, what does mean? Now, what does means if the test has 80% sensitivity? Okay, now if you are testing in a patient's population, okay, for a certain disease, and your test is positive in the patient's group, 80% is positive, then the sensitivity your test will be 80%. If you perform the same test in the healthy population, and about 90% of tests was negative because they are healthy, and the specificity your test will be 90%. Okay, now, what does accuracy means? Okay, accuracy, let's see. Okay, how close results are to one another is the precision. Okay, how close a test result is the true value is accuracy. Okay, the correct answer is B. Okay, not bad. Okay, a control is defined. Control is defined okay, standard, control, calibration. Okay, let's see. Okay, the control, okay, specimen that is similar to the patient's blood, known concentration of constituents. The correct answer again is B. Okay, comparison of instrument measure or reading to a non-physical constant, other definitions. Okay, the correct answer is B. Okay, now next one, sensitivity. Okay, what does sensitivity means or specificity means? Okay, cases that a specific disease or condition that produce a positive test result. Okay, let's see. Okay, A is the correct answer. Okay, next one. Okay, now go ahead. a quality control statistics, okay? Since that we are talking about the quality, we need to collect data, okay, about the quality results, okay? And this data, in order to get a result, you have to use some statistical analysis. Okay, mean, median, mode, standard deviation, and confidence intervals. Means the degree of a group of numbers, median, middle value of a body of the data. I am going to show you, and mode, the value most frequently occurring in a list of the numbers. Okay, the standard deviation, okay, is a measure of the variability in a data sets. Okay, and confidence intervals is a reference range expressed as 95% or two standard deviation on either side of the means. Now I am going to show you here that, as you see, what does mean, okay? If you have a that data sets like these, you are, okay, you sum up all these data, these numbers, since there are 5 different data, okay, and then you divide it by 5 and get a mean value, okay. If you sort these data from lowest to the highest, okay, the median will be the number in the middle of the list, okay. And if you sort the same data from lowest to highest and see the frequency of the data, the highest frequency of the data will be the mode. As you see, in this case, 72 is the mode of this data set, okay? Now, we know that statistically, the reference range of a particular measurement in most cases show a bell-shaped curve. Okay, this Gaussian curve or Gaussian distribution has been shown to be correct for virtually all type of the biological, chemical, and physical measurements. Okay, the distribution of all values around the average for the particular group measurement is described statistically by standard deviation. Okay, you have a average value, okay, and the data around the average value, above or below the average value, is known standard deviation, deviated from the average value. Okay, now as you see here, which we are using in the quality control statistics, these bell-shaped graph, Gaussian distribution. Here are a average value, X, okay? And then one standard deviation to standard 3 standard deviation, okay? If you accept one standard deviation, okay, in the both sides, and the confidence interval will be 68%. What does means your data will fall in between these two standards in 68% of your data will fall in this range. Okay, about 32% 2 points will be out of your range. If you accept 2 standard deviation, about 95% of your data will fall between this range, okay? 5% will be out of the range. What does means your confidence interval will be 95%, okay? If you accept 3 standard deviation, then 99.73% your data will fall between this range, 3 standard deviation, okay? Only a few of them will be out of the range. Now, okay, if we need to monitor the quality control, to the quality of your test, okay? In most cases, the instruments, they are doing by itself this, but in some case, we are using Levy-Jennings QC graphical data plots in order to identify unacceptable runs, then evaluate the source of and magnitude of the deviation to decide if results are to be released to the patient charts. Okay, now the Levy-Jennings graphs help us to follow the quality of our test. As you see, this is here our target value, okay? It depends on the lab which standard deviation is accepted. If the 1 standard deviation, 2 and 3 standard deviation, usually the labs accept 3 standard deviation. That means your confidence interval is about 99%. Okay, as you see, these results is out of control, higher, and higher, okay? And here you see these results, okay, is out of control because is out of the range of the 3 standard deviation, okay? And you see here imprecision, okay, and drift, as you see here, a sudden increase of the lab data, okay? Each of them has a different meanings. Now, okay. Okay, now we still have 20 minutes, okay? And if you want, I am going to stop in a 5 minutes and then give access to the quiz 1, okay? This is one option. A second option, I am going to continue at the end of the lectures and give access to you at 6 p.m. today. Which of them works for you best? In a 5 minutes, okay, 1:45 p.m. or 6 p.m.?
1:45.
Okay. Now I am going to...
Or 6 p.m.?
Yeah, either 6 p.m. today or 1:45, I mean, in 5 minutes. Okay.
1:45 is fine.
Okay. What about you, Trinity?
Yeah, that's fine.
Okay. Now I'm going to finish in 5 minutes, and then you will get access to that. Okay. Now, what does shift means and trend means? Now I'm going to show you with a graph. Okay, a shift is defined as sudden and sustained change in one direction of control samples. Okay, now you are measuring amount of enzymes as a control sample. And as you see, your results, okay, I mean, at the day of 8, after date of the 8th, they are on the same sites always, okay, and which is known as shift, okay. A sudden and sustained change in one direction, okay. As you see, okay, they shift to the below of the medians, and then they sustain it at the same site at least for 3 days. Now, trend or drift is a gradual change in the control of the samples. As you see, is gradually decreased day by day. It started with day of 11 and then decrease it gradually. Each of these changes has a different meanings in order to find out the source of errors. It may depend on because of the regions or because of the instrument, or it's based on the methods, the techniques that we are using. Okay, now Westgard rules. Okay, this is my last slides. Okay, we are using Westgard rules to accept or reject the test. Okay, which improve the quality of the test results. Okay, now I am going to show you here. Okay. Maybe, okay. Okay, the Westgard rules define specific performance to detect both the random and systematic errors. Okay, and there are different rules of the Westgards, warning rules, okay, and also the violation of the rules, as you see here, okay. If as you see here, if you accept 2 standard deviation, as you see, one of your control is out of the range, okay, is violated your rules, okay, the Westgard rules. However, in the same day, in the other control is normal, okay. Therefore, this we call as warning rule, okay, and you will accept this, okay. The warning rules, only one control is out of the range, other is normal, okay. If you have a result which is about 3 standard deviation, okay, which we call 3S rule, then you will reject the result. You don't release the patient's results, okay? Now let's stop here.